All right, hey gang. So for today, I've got a review with some story problems, basically, and they're not hard problems. I know when I say story problems, a lot of you kind of get this, like, are you kidding me, Mr. Cobbles? It's so hard, I gotta read and do math together. I'm just kidding. Anyways, but actually, I'm not. I shouldn't laugh at my own joke, should I? But what I'm trying to say is this: if you read the problems carefully and slowly, I really think you can understand what's going on. Okay, so I'm gonna give you some hints on a couple of these. I'm gonna do some of the harder ones. I think might be harder for you, and then hopefully you can kind of fill in the rest and get the rest of the problems done. Do I care if you work with a neighbor, partner, someone else that can help you out? No, by all means, work together. Obviously, don't cheat, but I want you to learn how to do these problems, learn how to think through the process of the story. So, in taking a look at some of the problems I've marked out, I'm going to get rid of my shots here so you can see the papers a little bit better. Okay. I wanted to do number one with you. Surprisingly, in years past, I think some kids have struggled with this one. And ultimately, it comes down to the very last sentence. What street corresponds to line AB? Basically, what they're asking is, well, what if I was to say there was a street that was in alignment with AB or was line AB, what street would that be? Okay, so that's all you need to do on that one is identify the street that is in place of line AB. Okay, it's basically saying how else could you name line AB? Okay, with the name of the street. Number two is another one that has given people difficulties in the past, and so I want to take a look at that one with you. I'm going to read the problem here. Marcia plans to fly herself from Gainesville to Miami. She wants to model her flight path using a straight line connecting the two cities on the map. So I'm going to go ahead and do that right now. I'm going to suggest that you are going to want to do the same thing with your map. Okay, but basically, let's just finish the problem here. Sketch your flight path on the map shown below, which we did, and approximate how many miles it is from Gainesville to Miami. Okay, so here's a suggestion. If I were you, I would measure this length with your ruler, and I would measure this length with my ruler, and then I would see if I could figure out what length this is going to have to be. Okay, and there's lots of different ways you could set that up, so I'm not going to comment anymore on that. I just want to see if you can figure it out. So that'll be the first page right there. On the second page, I wanted to look at number 3 with you. Okay. I've had kids struggle with this one in the past, and a lot of times it's as simple as draw the picture. Okay. So in number 3, it says a hiking trail is 20 kilometers long. Park organizers want to build 5 rest stops five rest stops for hikers with one on each end of the trail and 3 others spaced evenly between. How much distance will separate successive rest stops? So again, I'm a visual person. This is going to be a rest stop right here. And this is going to be our last rest stop. So the first and last, and I'm going to connect them. Okay. Now from here, there are 3 evenly spaced rest stops in the middle here. So if I was to go and do, let's see here. Here looks like it's half approximately. And here, and here. Okay. So these are all spaced evenly. So what I'm going to do is I'm going to mark them as if they are all congruent. Okay, now if you don't like the way I've marked that there, you think it's too busy, I completely understand. You don't have to put the congruency marks down. But now the question is this: how much distance will separate successive rest stops? And I think with the picture and the fact that you have the overall length, you should be able to figure that out pretty easily. Okay, so that's my suggestion for number 3. And I've got one last one I wanted to do with you, which is number 4 here. Okay, so in number 4, it reads this. The United States Capitol is located at 2, -4 on the coordinate grid. The White House is located at -10, 16 on the same coordinate grid. I'm sorry, did I say the United States Capitol, not the White House Capitol? The United States Capitol and the White House. Find find two different points on a segment joining the United States Capitol and the White House such that the ratio of the shorter segment created by each point is 1:3, okay? So what I'm going to do first of all, I don't think that I can go up to -10, 16. So I'm going to go ahead and say that each of these is a length of 2. So if I go to -4, remember this is x and this is y, and these are x and y. If each of these is 2, I'm going to go to -4. Okay, and I'll put that for the Capitol building, I'll put C. Okay, now for W, the actual White House, again, this is x and this is y. -10, 2, 4, 6, 8, 10, and 16. 2, 4, 6, 8, 10, 12, 14, 16. I'll say that that is W. Okay. Now, I want to figure out a point. It says here, find two different points. So we want to make sure we do two different points on a segment joining the United States Capitol and the White House such that the ratio of the shorter two segments created by the ratio of the two shorter segments created by each point is 1:3. Okay. So remember when we did these ratios, okay, we went ahead and drew the rise and the run. So I'm going to go ahead and do the rise this way and the run this way. Okay, and I'm going to count those two. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay. Now, what we're actually looking for, remember how to turn this into a fraction. You can use either number, it doesn't matter. I'm going to use the 1, and then you add the 2 together. If you use the other, you would be 3/4 instead of 1/4, okay? Now from there, I'm going to take, after I've drawn in the rise and the run, I'm actually going to go ahead and count the distance. Now remember, each of these is worth 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's the length of 20. 2, 4, 6, 8, 10, 12. That's a length of 12. So if I do 1/4 the rise and 1/4 the run, 1/4 of 20 is 5, 1/4 of 12 is 3. Okay? So if we go up 2 every time, 2, 4, 5, 2, 3, there's 1 point. Okay? That's one of the points. Divides it in 1:3 ratio. If I want to go from W, I could go rise of 5. So 2, 4, 5, 2, 3. Okay. Now again, that's an estimate there. 3 is in between the two. If I want to continue on with this, I want to show you what would happen. So if I do 2, 4, and I want to do 5, so there's 5, and then 3, 1 plus 2 is 3. And then 2, 4, 5, 2, 3. So this is one of our points, okay, and this is the other. And if you notice, here's 1, and then there's 3 on the other side, 1, 2, 3. So that's how we get that ratio of 1:3. Here's 1, and on the other side there's 1, 2, 3. All those lengths are the same, okay? So what are those values there? Well, it looks like we are at -1, 1. Remember, we're going over 2 each time, so be careful of that. So one of them would be at -1, 1, and the other one would be at -2, 4, 6, looks like 7. And then we are up 2, 4, 6, 8, 10, 11. Okay. So just something to think about as we work on these. I know it was kind of detailed there, but I hope I made the problem simple enough that you could fully understand what was going on. So, as before, if you have any questions, let me know. Don't forget about number 5 is on the back side there. I want to see what you can do. I wish you the best of luck, and we'll see you tomorrow.